In this video, we're going to try and find out the limit of 1 minus cosine of x over x as x tends to 0. So from the left-hand side, as x tends to 0, it will head towards here, and then the limit as x tends to 0 from the right-hand side, it will head towards here. Note that dead on 0 is undefined. So in the previous video, we looked at finding out the limit of this. In this video, we've got to find out the limit of this. You see, these two limits are very important. When we get to calculus, these two limits will allow us to find out the gradient of let's say your sine graph looks something like this, your cosine looks something like this. You see, these two limits will later on allow us to find out the gradient of this at any given point. So here the gradient is negative. These two limits will allow us to find out the limits of the cosine and the sine graph. So the point I'm trying to make is that these two limits are very important. You have to write these two limits down somewhere or memorize them. Okay. So in this video we're going to concentrate on finding out the limits of this. Okay. So to find out the limit of this here, the trick that we normally use is to times top and bottom here by the conjugate of this here. Okay, so looking at this here, times top and bottom by the conjugate of this. Okay, so here when you time this times to the top, it will look like this, and then here your x here is here, and then you times by this bubble here, which is this bubble here. Okay, that will take you to here. Now, whenever you see this here, remember this. This is very important. You should have this ingrained inside your mind. When you have a circle of radius 1, the hypotenuse here is 1, and the height here is sine. This length here is cosine. And when you use Pythagoras, which is 1 squared, that equals this squared plus this squared here. So this has to be ingrained inside your mind. Now when you are here, and if you take away cos squared, then you're going to have this 1 minus cos squared theta equals sine squared theta. You see, looking at this here, this is this here. So this here is actually sine squared theta, sine squared theta, and this remember thing, you have to have this ingrained inside your mind. Okay, so hang on, let's start again. We started out as this here. We want to find out the limit of this, so we would times top and bottom by the conjugate of this. That would take us to here. Now this bit here is actually sine squared theta. Sine squared x. So you would put that into this whole thing here. So hang on. So from here, this thing here is actually sine squared x. Okay. And then when you are here, visualize it as sine x times by itself. So you've got one block here times another block, and then at the bottom here, visualize this as this block times this block here. So basically, so visualize this whole thing here as this here. So rather than seeing sine squared x, then you would just visualize it as this block times this block, and then at the bottom this block times this block. So when you're here, you can then break you can break the fractions into two separate fractions. So if you look at this here, this times this will give you this bit here, and then bottom times bottom. So basically, when you're here, you can separate the fraction up into two separate fractions. So here you've got a fraction, here you've got a fraction. Okay. So once you're here, then you can actually break into it. So find out the limit of this, and then times it with the limit of this. Okay. And then, well, from our previous video, the limit of this here is actually 1. Remember, this has to be ingrained inside your mind. The limit of sine x over x is 1. Okay, and then when you take the limit of this, you see when you put 0 into here and into here, you are allowed to do this because nothing breaks down. Because if you look at this, if you put 0 into this sign here, sine of 0 is 0, and then at the bottom you have 1 plus cosine of 0 here is 1. You see, nothing here breaks down. Nothing breaks down. So so this thing here is really 0 over 2. Again, nothing here breaks down. 0 over 2, you are allowed to do, nothing breaks down. So it's not a case where you have 2 over 0. You see, this here breaks down, but this here doesn't break down. So when you are here, you can just simply put 0 into here because nothing breaks down. Okay, so the limit of this here is 1. The limit of this here is 0 over 2, which is 0. So 1 times 0 here is 0. So the limit of so our overall limit is actually 0. So this is what we were trying to find out here. The limit of this is actually 0. Okay, and so overall the answer is the limit of this is 0. But here's something else that's very important. Whenever you have a limit of a function that equals 0, the negative version of this here will also be 0. So for example, if you look at this, if you look at our function, it's doing this and it's heading towards 0. You see, if you take the negative version of this, let's say something like this, you see, the negative version of this will also tend towards 0. In fact, if you have any function, let's say you've got this function here, if the limit of this as x tends to 0 equals 0, then if you take the negative version of this function, which is, well, something like this here, it will also tend towards 0. Or if you have a different function, let's say this one here, and then like this, it's heading towards 0. Okay, all the way over here. You see, if you take the negative, hang on, let me start again. If you have a random function, let's say something like this, and it goes through the origin, then the negative version of this function here, which will look something like this, I don't know, something like that. You see, the limit of this here is 0, so that means the negative version of this function here will also be at 0. It doesn't matter what function you have. Let's say you've got a function looking like this. Okay, then the negative version of this function will also be 0. See, my point is that, you see, the limit of this here equals 0. So if you have a negative version of this function here, it will also be 0. So look at this here. So we know that the limit of this here equals 0. So this function here, let's take the negative version of this function, and the limit of that should also be 0. So this is our function here. Now times by negative 1, it will give us this. Okay, it will give us this here. So when you times minus 1, this times this, it gets multiplied to the top. Minus 1 times this, it will be a positive cosine of x. And then well, my point is that this then tidies itself to become this here. Well, the limit of this is also 0. But so we started out by knowing that the limit of this here is 0. Now that we then take the negative version of this function here, and the limit of that will also be 0. So my point is that, well, we started out as this 1 minus cosine. My point is that we found out that 1 minus cosine of x, the limit of that equals 0. Well, if the limit of this here equals 0, then the negative version of this, which is this, by the way, notice that this here is these two switched around. Okay, so this is your positive cosine, this is your negative cosine here. These two switch around. My point is that we discovered that this here, the limit of this is 0, therefore the negative version of this function here, so the negative version of this function here, the limit of that will also be 0. So these two are also 0. Sometimes we would switch in between the two. So just bear that in mind. Okay?